Okay, so to predict the products of a neutralization reaction, the key is to realize that as part of that neutralization reaction, one of the products formed is going to be what is called a salt. So technically a salt isn't just, what you put on your fish and chips or whatever. It is an ionic compound that is formed from the anionic component of the acid and the cationic component of the base. So if you can write the ionic compound correctly, so it is balanced and electrically neutral, that will give you the key to how to balance this neutralization reaction. So whenever you have an acid-base neutralization reaction where it's just a simple inorganic acid with some kind of hydroxide base, the hydroxide anion is actually the base. So these reactions will all follow the same kind of pattern, that the acid plus the base will form a salt, and the only other product that is possible will be water. Okay, so let's follow that pattern here with the nitric acid and the calcium hydroxide. Now, I know that acids, the bonding is molecular, but I'm going to treat it as if it's an ionic compound because I know that the acid is going to give up its H plus cation. So if I break apart the nitric acid, I can find that the anionic component is the nitrate anion, NO3 minus. And then I'm going to do the same thing for my base, which will break apart into the calcium 2 plus cation. And we have two of the hydroxide anions that are being liberated. So let's write the formula of the salt then. It's going to be the cation of the base and the anion of the acid. And as you can see, I'm going to need two nitrate ions to balance that calcium 2 plus. Okay, so calcium nitrate subscript 2 will give me my balanced ionic compound for my salt, and the only other product possible is water. So then I have to make sure that this is balanced. So I've got calcium on both sides here, but I've got two nitrate ions on the right side. So I'm going to have to put a 2 in front of my nitric acid. So that will now balance. Let me count up how many hydrogens and oxygens I've got. I've got 1, 2, 3, 4 hydrogens and 1, 2 oxygens. So I'm going to need 2 waters as my product. So once you've worked out the formula of the salt that is formed for the neutralization reaction, do double check and see if your reaction is actually balanced or not. Okay, a few things will determine how that will be balanced. Sometimes it'll be a one-to-one stoichiometry, but whenever you have a neutral salt where there is, two of one anion or cation or not the other, or if you have a diprotic or triprotic acid, so more than one H plus being given up by the acid, that is going to affect your overall neutralization reaction stoichiometry. So let's have a look for another one, just practice a few of them. So that is the same thing, pretty much. Sodium hydroxide versus calcium hydroxide. Let's do something else. Okay, so what have we got here? We've got HBr and KOH. So again, you're going to want to break apart the acid into a cation and anion, just pretending it's ionic. So H plus and Br minus. And then potassium hydroxide will give you potassium, K plus. And the hydroxide ion is OH minus. So our salt then must be the cation of the base, which is potassium, and the anion of the acid, which is the bromine, and that's just going to be 1-to-1, so it's going to be KBr, and the only other product is going to be water, and as you can see, that is already completely balanced. All right, I guess we can do another one. Oh, okay, a bit more fun. So here our anion is the perchlorate anion, so that is ClO4 minus, so H plus will break apart, give us our perchlorate anion, ClO4 minus, and then our cation of our base is Na plus and hydroxide. So we have Na ClO4 plus H2O, and again, that is already balanced. Okay, so get some practice with that.